So let's just go into the slides. Let's use the slide. Let me bring that up. I'll share my screen now. I want us to go into the lab work. A lab work. The lab work was supposed to be done in the last class, but since we don't have much to do in the lab work for today, the lab work for today should be installing R. So since we don't need to actually install R, we'll just go into the lab work that we're supposed to do last week, which is using Yarn for MapReduce. And that is, we're going to be looking at word count. We're going to be looking at word count. So a word count practice. So we're going to look at how to use MapReduce with our virtual environment. So let's quickly go into what we have to do today so that we'll be able to quickly look at that. I hope we're able to finish it. If we are not able to finish it, I would say that we should please finish it on our own. So, so very quickly, let me share my screen.
Hello everyone. So
yeah, Emmanuel, you are not clear. You're still not clear. I don't know if I'm the only one, but you're not clear.
Okay. So Abisala, I want to start.
Yeah. You. What did you say?
I want to start recording from here. Start recording.
Can you type what you just said? I can't hear you.
I think she's saying you should start recording. I think you're saying
I should start recording. It's recording already now.
Yeah.
Emmanuel, you're recording it. You started recording it already. Okay. All right, so sharing my screen now. Sorry for the delay. I didn't sign in before. All right. So can you see my screen, Hubert? Please let me confirm that.
Yes, I can.
All right, cool. Okay, so
confirm, so it doesn't seem like I'm the only one that's seeing.
What did you say? Okay, for another person to. Okay, let's get another person. I just want a quick response from everyone. That's why I want to ask. I want it to be that I'm asking just one person. Let me look for someone else that can always ask. Ibitamuno, are you here?
Yes, I'm here.
Okay, so please, when Hubert says you can see my screen, please help me second it. So once both of you would say you can see my screen, I would just assume that everyone can. And if there's anybody that can't, please bring my attention to it.
All right.
Yes, thank you. Thank you. If you cannot still see my screen, every other person, please let me know so that it's not like I'm just going forward and I'm not putting I'm not bringing everybody up to speed. All right. Let's go into today's work. So analytical tools. Yeah. Yes, today's objectives. We're supposed to understand the importance of SPSS, SAS, and compare these various analytical tools with one another. All right. So introduction to analytical tools. First of all, I would want to talk about the evolution of analytical tools. So previously, in about the 1970s to 1980s, the kind of computers that were used were mainframe computers, right? And then these mainframe computers were the only thing we could use to do analytics, because mainframe computers have high speed and they can accumulate a huge volume of data. So it's mainframe computers that were previously used. And then on mainframe computers, of course, there was no way to perform visualization. So you had to write a code, a query code, and this was called job control language. And this job control language was used in the 80s with mainframe computers. And then imagine you have to write so many lines of code just because you want to produce a bar graph, a bar chart, and a histogram, and so on and so forth. Well, previously, it was far worse than that, because all of these graphs, okay, even in this same season, these graphs were produced using dashes. So imagine you have to like print so many dashes just because you want to produce an image that looks like a bar, or you have to like type so many grids or something to be able to produce so many images. I mean, so many charts and so on. So control language was used, and then this job control language was what was used to write codes for analytics in the 80s. Sorry, I just want to quickly. Okay, all right. So it's a scripting language, and it is normally used on mainframe operating systems, like I said. So it helps you to run batch jobs. So it splits your jobs, just like the way I was explaining what Hadoop does. Oh, did I explain what Hadoop does? Okay, I did not. Probably your tutor for those classes would have explained what Hadoop does. Hadoop helps you split your tasks using the MapReduce algorithm. So it splits your tasks into subtasks, and then you have different nodes that work on different aspects of your data, right? So it completes this and then brings everything together and gives you a result. So that's the same way mainframe computers used to work. But then they used job control language to write this scripting, and this scripting was what was used to produce the charts and the graphs that we used to have in those days. But then now things have changed, and then now we have various visualization tools with beautiful UIs, that's user interfaces. We have so many tools that help us with workflow diagrams, and we all know what workflow diagrams are. Okay, just for those that do not know what workflow diagrams are, workflow diagrams help you to understand the steps in your process. So you create a diagram that shows that, okay, you are linking this particular table to this particular table, and then you're linking this other table to this other table, and so on and so forth. So from your workflow diagram, you can have a good picture of what your data is going to produce in a chart or in a graph. So now we have several things that come with these visualization tools: beautiful UIs, spaces for drawing your models and workflow diagrams, for example, Tableau and Power BI, and so on. So that's like a brief summary of how analytical tools have evolved over time, right? And then very quickly, let me see. I want to see if this has what I want to talk about. Okay, it has it. Okay, cool. So let me just go into the slide. All right, so introduction to analytical tools. Analytical tools are used to prepare data for analysis, execute analytical algorithms, access the results of the analysis. Yes. So it helps you to prepare your data. It helps you to extract your data, transform it, load it. That is preparation. That is preparation for analysis, right? And then you can also execute algorithms on these. You can write scripts that help you execute, that help you transform your data, and in turn you can use this to produce beautiful graphs that will bring meaningful insights. So you could also automate processes on analytical tools. So instead of having to for example, I own a sales company, and we sell goods for manufacturing. Probably we sell tires, raw parts. Sorry about that. I don't know who is calling me. Okay, so we sell tires, say for example, for manufacturing, and I want to know how many tires come in every day, how many tires are used each day, what percentage of tires are usually bad, what percentage is usually good, how much should I feel would come in the next day based on my historical data, and so on and so forth. All of these things can be put into a dashboard. I could just have a dashboard that shows that, okay, this is what comes in every day, this is what has gone out today, and so on and so forth. A simple dashboard will show me that. And this process can just be automated. So as my data is being updated, my graphs and charts are also being updated. So it helps you automate analytical tasks, right? And it also helps you to get more time to focus on analysis. So instead of having to write so many lines of code, like what the job control language used to do in the 1980s, because you have to like write a long code that then gives you the result you want before you now start visualizations, right? You don't have to do all of this. You don't have to write so many codes. All you have to do is just grab your analytical tool, get your data, transform it, and then visualize. So there is less time spent on coding and more time spent on deriving meaningful graphs and charts that in turn bring beautiful insights that businesses and organizations would use to improve their processes. So that's about introduction to analytical tools. So like I said, the evolution of analytical tools, I kind of talked about this already. I said it's done using a mainframe, and then job control language was used. And this happened in the 1980s. Then control interfaces migrated to new platforms in the 1990s. Like I said, new beautiful user interfaces were developed. We have better graphics now. We had better graphics in the 1990s. Better graphics came into play. Less coding, more of visuals. We had better graphics and so on. And then now in the 2000s, you can see, you know, if I start asking everybody to mention all of the analytical tools we have, we'll probably not finish mentioning them because there are so many. We just do not use all of them, but there are actually so many. So now we have sophisticated graphical representations, and we have beautiful tools that help us analyze our data. NIME, Spark, Power BI, Tableau, and so on. So many of them. So post 2000s, now we have so many analytical tools that we cannot even stop mentioning if we start mentioning them. So so that's that about the evolution of analytical tools, right? And then okay, so I would like to talk about point solutions. So point solutions, it's like developing analytical. I don't know if it's in this slide. I think I went through this slide already, but then I'm not sure. So let me just talk about it. Okay, see, yes, such as point solutions. So it's a key concept that I would like us to understand because I might refer back to it later in this class. So let's just go into categories of analytical tools since I have what I wanted to mention. So I'll just mention it as we move on. So analytical tools. So we have two categories of analytical tools. We have statistical data analysis tools, and we have data visualization tools. Now, statistical and data analysis tools. In statistical data analysis tools, we have all analytical tools on graphical user interfaces. So they all have beautiful GUIs, and then we can perform our analysis on them. Then we also have, now we've shifted more to utilizing these tools to create visuals instead of coding, like I said. So we have these tools that have made us spend less time on coding and more time on utilizing these tools to create visuals. So we also have point solutions. There are new packages that have come with point solutions, and point solutions is just basically using software packages, right? Using software packages to address a particular type of problem. So for example, I could develop a fraud application that specifically helps me to detect fraud. Now, with that, I have less time spent on extraction of data because it already knows what data to extract. I've already assigned a particular kind of data to it. So it just has to extract things that have to do with fraud and not everything that my company does. Say my company does other things like forecasting and all of that. I just know that, okay, this application helps me detect fraud. So it spends less time on going through the whole data set and just focuses on those that have the fraud tag on top of them. So I can have packages, special packages that address a specific kind of problem. And this is called analytical point solution. So that's about point solutions, right? But then there are some limitations to point solutions. They are expensive and really, really expensive. But then if there are enterprises that are big enough to afford them, I believe that they are worth it because they help you address a specific problem. So you don't have to go round and round and round to get the solution to a particular problem. It is just directly on your point solution. You could just check your fraud application, and from a fraud application, you can see, oh, okay, there's a possibility of this fraud happening, and so on and so forth, of fraud happening today, or a possibility of this particular customer committing fraud, and so on and so forth, because it specifically addresses the problem of fraud in that company. So that is about fraud point solutions. So let's move to data visualization tools. For data visualization tools, it doesn't only analyze data, right? It also helps you with reporting. So reporting is developing beautiful graphs and visuals to represent your data. I'm sure we've understood the meaning of reporting in our previous classes. Just to recollect, analysis is when you have to study your data to develop patterns from it and insights in it. That is analysis. That's analysis of data. And then reporting is when you have to put your data into visuals and graphs, the data that you need, the needed data, not just all of the data, the needed data. For example, say from January till now, 2020, that is the needed data. So the needed data is put into a report, and this helps you even generate better insight. So reports help you see insights better than analysis would. And sometimes you don't even need reports to see insight into a particular data. For example, if I have, say, 10 rows of data, I could just look at it, and from looking at the data, I can derive insights. But there are sometimes you have tons and tons of data, and then looking at tons of data would not help you generate insight. You have to move into reporting. Now, reporting helps you summarize your data, and then from your visuals and graphs, even an average businessman would understand the message you're trying to pass across from your reporting. So that is that about visualization, analysis, and reporting. So this is what data visualization helps us with. It helps us with reporting. It helps you present your data in forms that are understandable for the average business professional. So yeah, so knowledge check. Theo, the marketing manager with Nelson Pharmaceuticals, is planning to start a new project. Therefore, he needs to predict the headcount for the next year to estimate product in line, productive man hours, budget, and other such parameters. Which of the following ways should be used to accurately and efficiently predict the manpower requirements? So you want to, Nelson Pharmaceuticals wants to start a new project, and it wants to predict the headcount for the next year, to estimate product in line, and to estimate budget, and to estimate man hours, and so on. So they're asking us which of the following ways should be used to accurately and efficiently predict manpower requirements. You cannot do this manually. Like, you are going to sleep on it. It wouldn't make sense at all, right? Assign the tasks to each responsible department and later accumulate the results. That doesn't make sense, because assigning the tasks to each department would waste your time. It is a wastage. It's a total wastage of time. You have to assign to this department, and then this department works on it. What if this department is not ready on time, and so on and so forth? So this would not accurately and efficiently give you the results you want. Build a special team to do this. No, you do not need a special team to do this. What if you have a special team and you do not have the appropriate tools to be able to get this work done? So the best answer is to use the appropriate tool and data from all the departments. So gather the data from all the departments, use the appropriate tool, and then you can efficiently predict the requirements for Nelson Pharmaceuticals to be able to produce, to be able to estimate their product in line, and the rest for the next year. So that is that about introduction to analytics. Let me welcome questions before I move on. I've been talking. I'm trying to quickly round up this part so that I'll move into practical. So sorry if I'm talking too fast. I appreciate comments. Comments or questions, please, before I move on. If there are no questions, just say something. I'm too fast, I'm not too fast. You understand, you do not understand, you have a question, you have a contribution.
You're not moving too fast. The class is very clear, man. Thank you
Go
very
ahead,
much.
man.
Yeah.
Okay. Okay. All right. So no
Can you hear me?
questions. What did you say?
Okay, I wanted to be sure if you can hear me. Sorry.
Okay. Yes, I can. I heard
Okay,
you.
thank you.
Okay. So if you have any question, just let me know. And of course, I'll ask at the end of this theory session. I'll ask if there are any questions. But if you have any question along the line, you can just raise up your hand to let me know that you have a question. All right. So let me move on. Okay. So then there's another question here that says, which of the following characteristics represents data visualization? So which of the following characteristics represent data visualization? Distinguish between numerical outputs and mathematical models to understand the model behavior. Data can be displayed in spreadsheet or as a graph. Evaluate doubts in observations and its calculations. Build logical models for a system or process. So of course, you know that data visualization, like I said, has to do with charts and graphs. So even seeing data can be displayed in a spreadsheet should have already let you know that this is the answer to the question. So data can be displayed in spreadsheet or as a graph. So this is what represents data visualization. These other things are just processes in data analysis. They are not data visualization itself. But then displaying your data in a spreadsheet or a graph is data visualization. Okay. Moving on. So yeah, the part I like, the popular analytical tools that we have. So the famous R. I'm sure we've all heard R at one point or the other, probably when we wanted to start this data analytics journey, or probably when we just started these particular classes. Some way, somehow, I'm sure you've heard of R, and then you know that R is an analytical tool, but then you do not know how to use R. And I'm sure some of us probably know how to use R, but then probably not very well, and maybe some of us are experts at it. Whichever way, we've heard of R, and we have an idea of what R does. So let's quickly go into R and what R does. So R is an open source analytical package, or you could also say it's an open source statistical package. And it also helps, it complements, one thing I like about R is it complements commercial analytical tools. So you can use R in other tools. You can integrate R into Power BI. I don't know, I'm sure about Power BI. I love Power BI, so I'm very sure about Power BI. But I know that R is open source and is flexible. So you can complement it with other tools to produce your visualization. So you could decide to integrate an R visual into your Power BI, for example. So R is very flexible. It allows you to add more packages. So R helps you add more packages on it. There are so many packages that have been added by different individuals at one point or the other on R. So which makes R very open source, very flexible, and it is largely used by analytical professionals. So it was developed by Robert Gentleman and Ross Ihaka. I don't know how to pronounce that, Ihaka or something. And then, of course, you can see their name starts with RR, which tells us that this was where they got the R name, so to say, from. And R is a descendant from S. S is an early language. And S was used for statistical analysis in the past. So, okay. A second, please. All right. So, yes, as I was saying, R is a descendant from S, and then S is an early language. It was an early language that was used for statistical analysis. And there were so many things that came with SAS and with S, statistical computing system, and so on and so forth. So basically, it was just used in the past, and it was common for analyzing data in the past, for statistical analysis rather, in the past. So R is a descendant from S, and then it was from S that the famous R was produced or was brought about. So that's about R. So there are some features of R it is object-oriented than other analytical tool sets. You can link it with other platforms. You can link R with other platforms like C# and Java, and then you can also embed R within other applications. It allows for add-on packages, so you can add new packages. If you are a developer and you're very good at what you do, you can add packages to R. You can work on already existing packages to develop new packages. Probably you discovered that there's this package you like, but it does not have some features, and you can add some features to it to make it useful by you and even by other developers or other, and no, not developers now. Yeah, maybe by other developers too, and then by other analytical professionals or analytic professionals. You can develop it. You can add to that package and call your package something. Say your name, or so to say. So R is very flexible, and it is very useful for analytic professionals. So what again feature of R? It allows for modeling and it allows for analysis too. So that's that about R. And so okay, we're just going to go into the limitations of R now. All right, so R is majorly used in the academic and research environment. Yes, a lot of people use R, like I said, because R is very flexible, right? So it is used by a lot of individuals in the academic environment. They use it for research and so on and so forth. All right, limitations of R. Scalability. So R software runs in memory. It doesn't run against file. And because it runs in memory, it has a limit to the amount of data that it can take. So the limit to the amount of data R can take is the size of memory available on your machine. So whatever the size of your machine memory is, that is the amount of data that R can handle. If you put more, it cannot handle it. So sometimes for large organizations, you cannot use R because large organizations probably run data that is larger, a lot larger than what your machine can take. So sometimes you might not be able to use R in some kind of organizations. And then R interface is not as mature as other interfaces. It is not beautiful, so to say. It does not have a very, very nice graphic user interface. So that is the limitation of, those are the limitations of R. All right. So yes, let's move quickly into SPSS. Now, we're going to be going back into R because R is our major focus for this course. We're going to look very much into R. But then let's just look at these other statistical tools before we move into R. Okay, we're not going to move into practical session for R today, but we'll be moving into practical session for R on Wednesday. We'll be doing something on MapReduce today, but then we'll be moving into R practical session next week. So let's quickly move into the next analytical tool, which is SPSS. So SPSS was first introduced in 1968, and then it was changed, the name was changed into IBM SPSS when it was acquired by IBM Group. We all know IBM Group now, right? So it was acquired by IBM Group in 2009. So that's when it was changed into IBM SPSS. And it has a very friendly, user-friendly GUI, unlike R. R's GUI is not very user-friendly. So some features of SPSS. SPSS commands are executed line by line, right? So from line to line to line and so on. And then their syntaxes are usually stored with execution time. So when you write a syntax, it stores the time that you executed that particular syntax. And then it's available on several environments. You can get on Windows, Mac, and so on. And you can also integrate R functions into SPSS. And you can also perform data management functions on it, aggregating data, sorting data, and so on and so forth. So those are the features of IBM SPSS. And something about SPSS is it can only provide insights to your data based on historical data. So it only provides insights based on historical data, and we know what historical data is. Historical data is data that you already have, data that you have up until today. That is historical data. So it only provides insights based on historical data. Let me quickly see. Okay, I just wanted to check that everybody was still here. I've been talking since. So it only provides insights based on historical data. So that is about features of IBM SPSS. All right, so let's move into the next slide. Yeah. So next, we're looking at SAS. SAS is another analytical tool, right? SAS is Statistical Analysis System. It was found in 1976. It was found in 1976. Sometimes some people complain I talk too fast. So yeah, I get that a lot. So I'm shocked that nobody's saying I'm talking very fast. Well, let me ask you people. Who bats? Am I talking too fast?
I'll just say you're fluent. You're not talking too fast, don't worry.
Okay. So people actually complain that I talk very fast sometimes and they can't hear what I'm saying. Funny enough, the way I'm talking currently is like the slow version. So pardon me. But it's good that you people can hear me. I'm glad you can hear me. All right, so let's go back to SAS, Statistical Analysis System. So it was found in 1976, and it was designed to handle huge volumes of data, like large volumes of data. So it was formerly used in the IBM mainframe. I told us about what mainframe is about. Mainframe computers, where you have huge computers. If you check, just Google mainframe computers, you see they are huge computers, and these computers are designed to handle large volumes of data, and they split tasks and they make tasks run very fast, right? But with evolution now, we don't have to have so many big systems. Although some companies still use it, I don't know, but then that is what mainframe was designed to do, to handle huge volumes of data. And then SAS was the analytical tool that controlled this whole process, and it's an information delivery system. It uses packages. It's integrated. You can integrate it into your computers, and then it's independent, basically. So SAS is still used by a lot of companies today, because it handles huge volume of data, and a lot of companies want analytical packages that can handle huge volumes of data. So it is modular, it is integrated, and it is an independent computing package. So it's an independent computing package. And then there are some features of SAS that I'll probably know. I'm sure some of us have heard of SAS. Of course, we know it's used for statistics. It is used for text mining, data and text mining. It is very good for text mining, by the way, because it can handle huge volume of data. And when we talk about huge volume of data, we are talking unstructured too, unstructured data. So you need something that can handle a huge volume of unstructured data. For example, Facebook data, and so on. And then it also handles data visualization good enough. You can use it to forecast, and it helps you to optimize your processes. It also helps you for quality improvement, because you know that you're working with something that can handle huge volume of data with low percentage of error, or with low probability of error. So very quickly, let me talk about data and text mining. This might be a strange term to some people, I don't know, but then let me just briefly talk about what data mining. So data mining is when you are exploring huge volume of data sets, because you want to find unknown or hidden insights. So you want to get insight into your data. So you take the data and you explore it, you analyze it, because you want to get insights. So that is what data mining is about. Text mining is also the same thing, taking huge volume of text. You're trying to analyze it, but then the kind of analysis you do on text mining is descriptive and predictive. So you're trying to understand the kind of data. So descriptive is you're trying to see that, oh, okay, this particular kinds of text are telling me bad things. this particular kind of text are telling me good things, and so on. So you're trying to understand the meaning of those words in your huge volume of text. So, and it is majorly used for text-based documents, like I said. So yeah, analyzing huge volume of text. So that is what text mining is about. So those are the features of SAS, which is statistical analysis system. And then you can see what it's designed for. It helps you with to provide good information. It helps you with decision making. It helps you with good data management, and so on and so forth. So it helps you with guided decision making. I said that already, and so on. So that is what SAS does, and SAS is still a very useful tool today. All right. So let's quickly look at the comparison between different analytical tools. So we have R, IBM SPSS, and SAS. So let's see, user interface. For R, least visually interactive analytical tool, meaning that it doesn't look so good, but then it is still a good tool to use, right? But then it doesn't have a beautiful GUI. And they said editors are available for programming GUI support for programming in R, available for providing GUI support for programming in R. So, of course, user interface is good for you to do your programming and to put your scripts, type in your syntaxes and all, but then it just doesn't have a very good looking interface, right? Then IBM SPSS supports a moderately interactive GUI, meaning that it is not as interactive as SAS is, but then its GUI is fairly good. But SAS has the most interactive GUI. So that's about user interface. Then for decision making, R lacks the application of tree algorithms. So tree algorithms like decision trees, cluster analysis, and so on, that helps you to group your data. So it doesn't have the algorithm for that. So that's one of the things about R that is not good enough, because decision trees are usually used for predictive modeling. They're used in machine learning, data mining, and so on. So Python is good for that, but R does not have the application of these tree algorithms, and then it provides lesser user-friendly solutions. So solutions that are not user-friendly enough. R doesn't provide solutions that are user-friendly enough. Let me say it like that. So that's about R. Then for IBM SPSS provides the best and economical statistical solutions. So if you want to do perform health analysis, so to say, maybe you want to analyze, or maybe you're working on a project, a short project in school, probably in final year. I just want to analyze a few lines of data, maybe not too many. Say you had a survey, you conducted a survey, and then you want to analyze the survey. SPSS is very good for that. So it's economical and it helps you with simple statistical solutions. SAS is used for big data, so you can use it for data mining, and it also uses decision trees. So you can use it for predictive analytics, you can use it for machine learning, predictive modeling, and so on and so forth. So that is that about decision making for R, IBM SPSS, and SAS. So still comparing analytical tools, let's look at data management. So R supports poor data management techniques, as data has to be loaded into the memory for execution each time. So anytime you want to execute, you have to load data into the memory, right? Every time. So it doesn't have a good data management technique that helps you load your data. You have to load it each time you want to perform analysis. And IBM SPSS provides moderately performing data management techniques, while SAS provides excellent ones. Documentation. Its documentation is very easy to understand. That's why R is very good for starters. If you're coming into the analytics space, R is a very good place to start. So IBM SPSS, it has a limited use. So, okay, someone wants to say something. Okay, all right, that was a mistake.
Okay, yes, I wanted to say something.
Okay.
Sorry, can you go back to that slide?
Okay.
You said R supports poor data management techniques.
Yeah.
So for SPSS and SAS, how can the data be loaded to these softwares for data management aside loading it manually like R?
Okay. I don't know much about SPSS and SAS, right? But then I would say that why they are saying this is, in data management, you need data warehouses for your data to be adequately stored. I know data warehouse is like a house that accommodates all your data, your necessary data. So for example, you can build a data warehouse to accommodate the data you'll be needing for a particular project. So in R, you cannot build data warehouses. Do you understand? You cannot build data warehouses in R. But in SPSS, you can input your data, put them into a data warehouse, and refer to them subsequently. So SAS provides a good technique for that. In SAS, you can build data warehouses. It helps you with your data governance. You can get a place to accommodate all your data on your SAS software. But for R, you cannot build data warehouses on R. You have to load it into the memory every time you want to execute. So you have to do load data anytime you want to. Even if you have you've used the data before, you have to load it again anytime you are coming into your R interface. But for SAS, you can have a data warehouse that houses this data, and then you don't have to load it every time. It is already in that data warehouse. You don't have to load it into memory again. It is already there. SPSS probably provides a fairly moderate approach to that. I don't know much about SPSS, but then it probably provides a fairly approach to that, right? But I know SAS provides a good chance for you to build a data warehouse that houses all your data on the platform. So you don't have to load your data each time into the memory. So probably SPSS provides a simpler approach to SAS, but not as efficient as SAS is. We all know SAS is like the boss. But then R doesn't have an option for you to create a data warehouse to house all your data. Do you understand?
Yes. Sorry, I was on mute.
Oh,
I do. It's quite
okay.
clear now.
Okay. All right. So that is that about that. So I will not provide a data warehouse for you. You have to load your data into memory every time. All right. So for documentation, I told you that documentation is very easy. You can read through the documentation. SPSS is not really used. The more reason why I don't know too much about it, because R and SAS have taken over the market. R is used in place of SPSS, and then SAS is the one used in big organizations that have huge volume of data. So it doesn't have so much documentation online, so you cannot see much of this documentation online. While SAS has a comprehensive and technical documentation of over 8,000 pages. So SAS is widely used, and like you can see, it has a very, very comprehensive documentation. So if you want to learn SAS, you might have to go through some 8,000 pages. Yes, so that is about SAS and R and IBM SPSS for documentation. All right, so let's check our knowledge. Which of the following characteristics does not support R2 for easy analysis? Like we said, you can use R for object-oriented designs. You can use it to model your data. You can use it it's good for extensibility. But for scalability, no. Meaning that you cannot build a huge scale of data on your R platform. You can't say with increasing data, right? As your data increases, as you have more volume of data, you might not be able to use R. So it is not scalable. It is not scalable. So that's about R. So R2 is not supported for scalability. Scalability in R is quite low because with more volumes of data, you might not be able to use R2 anymore. You might have to move on to SAS. So, but extensibility, I told us that R supports it. You can extend it. You can put it on other platforms. You can add more more packages to it, and so on. And normal modeling of your data, logical modeling of your data, you can use R for that. You can also use it for object-oriented designs. So a minute, please. Okay, so that is about that part. Let me take any questions. Are there any questions? If you have any question, please let me know. Okay, no questions. So I'll just move on. I guess we all know what object-oriented design is. Okay, let me just quickly say it. Your object-oriented design is you're just structuring a program and then a software program, and then you're just breaking it into simple codes, into simpler codes. So you can use R2 for that. You can just break a software program into simpler codes, and then you can, and it's in R you can break down your code, your software program, or what it is you want to achieve. You can have smaller codes for each part of what you want to achieve, and then bring them together. So R supports that. Taking one object at a time, taking individual instances of objects, and then using it to create blueprints, using it to create blueprints of your final results, of the result you are trying to achieve at the end. So it's good for object-oriented design, but scalability, no. Because as your data increases, you probably might not be able to use R anymore, because R doesn't support huge volumes of data. R only supports the amount of data that your memory can take in. So that's about R. And then let's check this knowledge check too. A sports goods manufacturing company wants to analyze the reorder and inventory levels for its manufactured goods. Oh wow, I want us to start practical by 11. Which of the following features of SPSS will help the organization to perform this analysis? You want to analyze reorder and inventory levels for its manufacturing goods. They're asking you which of the following features of SPSS will help you to perform this. So we all know that is statistical feature of SPSS. If we go back to SPSS features, oh, it's in the previous slide. I just want to quickly show us that SPSS features. You can see that it is used for statistical analysis, and you can use it for aggregation, transposition, and so on and so forth. So coming back here, you can see that SPSS is good. It's which features of SPSS? It is not data visualization, definitely. It is not forecasting. I told you that SPSS is for historical data. That is data up until date. Data manipulation, hell no, no. Statistical analysis. You want to analyze reorder and inventory levels. So it is statistical analysis that is best to perform on SPSS for this kind of analysis. So and then for this knowledge check, Kent, a data analyst with Maramia Consultancy, has been asked to analyze clients' requirements and propose an appropriate solution. One of the clients is a mobile manufacturing company that wants to allocate its resources most appropriately. Which feature of SaaS would be best suited for this client? So you want to analyze clients' requirements and propose an appropriate solution, right? And you want to allocate your resources appropriately. You cannot use a data visualization feature, no. Forecasting, no. You want to propose an appropriate solution. All you want to do is analyze clients' requirements. So the best thing to do is to use an optimization feature. An optimization feature will help you to allocate your resources appropriately, because you want to propose a solution that helps you manage your resources, that helps you optimize your resources well. So most likely you would want to use an optimization feature. You are not improving quality of anything. You just want to allocate your resources in a way that optimizes your needs or your resources. You want to allocate resources in a way that optimizes your solution. You don't want something that probably wastes your resources, right? So you wouldn't use a quality improvement feature for that. You wouldn't use a data visualization feature for that. We are not trying to create a visualization. We are not trying to see anything. We just want to allocate our resources appropriately. So you would use an optimization feature. for that. And this is one of the features of SAS optimization. So that is about knowledge check 5. And then these are just points to remember. All right, so we're done with the theory parts. I'm glad we were able to finish before 11. So we're going to be moving into our virtual environment now. If you don't have your virtual environment open, please start opening it. And then if you cannot open it or you don't have it installed yet, you will just have to follow along. Before we move, I would like to ask if anybody has any question. If you have any question, please let me see your hand. Like, just raise up your hand if you have any question before we move on. Any questions, please? Okay, Adedeji, yeah, Adetoro.
Thank you very much, Ma.
Okay.
I just want to confirm, while you were talking about SAS, you said that it is designed to handle large data, and
Yes.
then you are now talking about mainframes, that SAS was a tool that was used in mainframe computers, right?
Yes.
Okay, so
No. SAS was a tool using mainframe.
when you're talking about SAS,
Okay, I said SAS was a tool using mainframe. Okay, yes, I'm listening.
okay. So I just
Yes.
wanted you to just shed more light between Hadoop and mainframe. Like, since Hadoop is also a framework that is used to manage large data, I just wanted to understand, is there any link or is there any relationship between mainframes and Hadoop?
Okay. So mainframe is an old version of computer, right? So if you check mainframes online, you will see that there are very big computing systems. And these big computing systems help you to handle large volume of data. But for Hadoop doesn't use, okay. So these are they're very big systems, right? And they help you handle a large volume of data. But then okay. So they are huge systems, like very, very big systems, and then they are not flexible because they are very huge. So you practically have to have them everywhere you need them. So that's what was used, like I was saying, that's what was used previously in the 1970s. The mainframe computers were used to handle this huge volume of data. And then for mainframe computers, you had to code. You had to use JCL, which is job control language. Is that what I called it? I think I called it job control language. Yes. So that was the analytics. That was the analytics you need to. That was the language you needed to perform analytics on a mainframe in the olden days. So without coding, without the job control language, you would not be able to perform analytics with your mainframe computers. So you had to code on your mainframe computers for your mainframe computers to be able to share this work and perform analytics. So you had to practically do everything manually yourself for the mainframe computers. And then, like I said, okay, you were saying that I said that SAS was found in IBM mainframe to handle large volume of data. Yes, SAS was formed in IBM mainframe, right, in 1976. But then today you have updated versions of SAS that you can do on your smaller systems, on more handy systems, on systems that you can carry around, on systems that are flexible. So but for Hadoop can be done on your virtual environment, for example. Hadoop can be done on your Linux environment. You can perform Hadoop functions on your Linux environment, and you don't have to code everything from scratch. You don't have to write so many lines of code. With just few lines of code, you can get your work done on Hadoop. Unlike mainframe that you had to code every single thing you needed to perform before you could get your results. So that is the major difference between SAS and Hadoop. Hadoop can be done on your systems, on your virtual environment, for example, and so on. Unlike mainframes that had to be placed in a room, big computers, huge computers, and then the individual has to sit down in front of probably a kind of system and he has to code every single thing, or she has to code every single thing that needed to be performed. All the analytics that needed to be performed would have to be coded using the job control language. So SAS was also formed to be able to be used on mainframe computers. But these days we have SAS that can be integrated into our Windows and Linux environments, and then you can also perform SAS on your smaller computers today. So that is the difference.
Thank you, ma'am.
You're welcome. I saw someone mention. Okay, yeah. Okay, can go on. Yes, please.
Question I have is, you said, question I asked is that you said that R does not offer scalability, but then we're using R for big data analysis here.
Yes.
Okay, is it because of we're using Hadoop with R that's making it function well? Because if R does not have enough scalability and we're using it for big data, isn't that a big contradiction or something?
Okay. So using just R, right? Like I said, R can only contain as much data as is on memory, right? But then in Hadoop, you can use R with Hadoop, and with Hadoop, you can handle huge volumes of data. Integrating when you use R with Hadoop. But R on its own, we're talking about just the analytical tools. That's why I said R cannot handle more data than is your memory space. So whatever is your memory, your machine memory, that is the amount of data R can handle. When it even starts handling data as huge as that, it begins to want to crash. So, but R with Hadoop gives you extensibility. Gives you scalability. Sorry for that. I meant extensibility, scalability. So Hadoop helps you handle huge volumes of data. So using R commands on Hadoop, definitely you'll be able to handle more volumes of data than R would ordinarily itself handle.
Okay, thank you very much. I want to just be sure. Thank you very much. Appreciate that.
You're welcome. Yep. Any other question? No question. Okay. In the absence of questions, if you have your virtual environment installed, can I see your hand? Just raise up your hand. Yes. One.
Sorry, are you talking about the VMware?
Yes, VMware, yes. You've used it now. You used it in the last class, right?
Yes, but I'm quite having some issues with it right now.
Okay, what issues?
I don't know, I can't move on to, it's not even showing me where to click after launching the software. I've tried putting it on the group chat. I don't know if I can share it on the chat box here.
The best thing to do now will be, because if we start handling that, we might not live here. Emmanuel is very much in charge of that. Emmanuel would be in the best position to handle that.
Okay. Do you think my network has to be on before I can access the VMware, or?
That I'm not sure of. Do you know why I'm not sure? I'm not sure because my data is always on. So if you ask me, I might give you an answer that is wrong, please. So I'm not sure because my data is always on, and since I've been using the VMware, I just have my data on all the time. So I will not be able to answer that right away. But Emmanuel will give you an answer to that. Where is Emmanuel? Emmanuel is not here. I don't think so. Wait, let me ask others. Everyone that has our data is on because we are on
Actually,
Teams.
when I came around on Saturday, my data was not on when I was doing it. So it actually works
without data. All right, cool. So it's actually okay. I think it's like an application. on your system. So it shouldn't work with data. I think it needs connection when you are installing some things. So when you start working with it, there are sometimes that you need to connect to the internet to download some things when you start working very much with your virtual environment. But to open it up and perform basic functions, like do basic things, I don't think you need your internet. Yes, thank you very much for that. So you don't need your internet to be on to open your VMware. It's only when you want to do some other things on your VMware that requires connectivity that you need your data on. So so for your VMware, I'll prefer that Emmanuel handles that. If I handle it now, we might take the whole time handling that. So I prefer that after this session, we get Emmanuel to come in and then he handles every issue that anyone has with VMware installation. I'll just call him if he doesn't come on before the end of this class. But for today, let's just follow along. Right? Is that okay?
All right. It's fine.
Okay.
Thank you.
Okay. Yeah, you're welcome. So you have this in your manual. I would like us all to check our manual. If you have your manual with you, you can follow along. We have it in our manual, but let's just do it together since we still have some time. So we might not be able to finish
Book 1 or
this.
Book 2, sorry.
Lab book, your lab book. MapReduce, your lab book, yeah, your workbook, yeah. Sorry, your workbook, Big Data Analytics Lab. So that's what we're looking at.
Sorry.
You can drop your hands. So we're looking at MapReduce, execution of word counts, case study. All right. Let me open this. So you can follow along with your books. If you have your books, you can follow along. So I'm sure we've learned about MapReduce and we know what MapReduce does. So MapReduce algorithm, you know that it helps you divide an individual task into smaller subtasks, right? And then we have different components. We have the components rather. We have the map reducer. We have the mapper, reducer, and the driver. And then all of this, both the mapper and the reducer, are executed from the driver process. So that is that about MapReduce. I don't need to go back into all of that. So today we are going to take a text file, and then we're going to find the frequency. We want to find the frequency of the words occurring in that file. So we'll take the text file as our inputs, and then we'll count the number of words that appear in this text. So then after counting these words, we'll categorize them into positive or negative words. So the idea is there's a restaurant, right? A reputed restaurant, and then this restaurant has a large volume of unstructured data. And this restaurant wants to collect, has collected data from various sites, Facebook, Twitter, Instagram, and all of that. And then the restaurant wants to gather this data together, and from this data, know the words that are most frequently used, categorize them into positive and negative words, and then based on this categorization, be able to make business decisions to know whether the customers like this new product or did not like this new food, or they want us to do a better food, and so on and so forth. So they just want to analyze the text, their text data, their customer feedback. They collect customer feedback. They collected customer feedback, and they want this data analyzed. So that is the background of what we're trying to do. So we want to analyze this data. So let's open our VMware. My VMware is opened already. So let me just open it. And let me close this. Okay, so I was just trying to look through. Let me close this one. I don't have it here. Stay here. Actually prefer it smaller. Okay. So, oh no, we're not using this today. So we are using, I like the terminal a lot. I like the color. Black. I like black. So sorry, let's move on. Sorry for the breaking transmission. Okay, so we're going to be using Eclipse today, and Eclipse is a platform that is used for MapReduce programs. So on Eclipse, you can it's a development tool that is used with MapR and it's used to perform MapReduce programs. So I'm sure Emmanuel has taken us through how MapReduce works, and you can read up. You can read up even if you didn't cover it. Just read up, check how MapReduce works, so you'll be able to understand what we're trying to do. So Eclipse works with MapR, and it is used to write MapReduce programs. So we're going to open up Eclipse now. And let me just, you're not supposed to have all of this. I was just trying to. Okay. All right. So open up Eclipse. So I'll just be working with this. If you are not up to, if you are not following, or I'm too fast, just let me know. Let me know. So you can follow your lab workbook too. All right. So from the lab workbook, it's telling us that this would open up. So let me get a reply from 2 people that I've opened up my Eclipse and it's working well and I'm following. Any 2 people. Do you have Workspace Launcher opened just like this? Anyone?
Yeah, I have mine open, but I would like to know the exact page on the lab book that you're working on.
Okay.
Page 24.
Okay, thank you, editor. Page 24. So you have it opened. That means editor too has it opened. So I'll just move on. Anyone has any issues with this particular screen? Like, can you see this? Can I get like 3 replies? Is everyone here?
Yes, Maria. I am.
Okay. So I'll be asking every 10 minutes to know that everyone is following. So 11:15, by 11:25, I would ask to know that everyone is following. So I'll just be moving, and then at the end of 10 minutes, I would like to confirm that everyone is moving. So if you have this, and if you don't have this, try to type this in. We just want to follow the book, right? So we just want to, what we want to do now is we want to choose a workspace for our folder. And we're choosing workspace home in HD user in home, workspace in HD user, and this particular workspace. So this particular workspace we'll be using for our project today. So let's click OK, which tells us that you've created a new workspace. Okay, so it's opening up what I did before. Okay. All right. Okay. So now in your workspaces, right? it has opened. If you notice, it's open. It's probably opened up. Welcome to Eclipse, right, for everyone. So if now that it has opened up welcome to Eclipse, if you are following your book, it's told you to click on Workbench. So please click Workbench, because I'm not going through that process now. I already did all of that. So please click on Workbench. Let me know that you've done that. I don't know if I can. So after you click on Workbench, you will have a new open space here. So let me see. Oh, sorry about that. Please, just a second. I want to try to follow everyone. All right. So we should have this particular place showing, although with nothing inside. No, we don't have any tabs open. Just ignore my tabs. Probably don't have any tabs open, right? So, or best to, let me just remove this. I don't want to delete this. Okay. I'm trying to follow along with us. I don't want my screen to be looking very different from what every other person is doing. So just pardon me. I should have done this before. Okay, I want to bring back space. I really don't know how to do this. I want my interface to look exactly like your interface, but I cannot get around it right now. Okay, has anyone used this interface before? I'm trying to bring back that part. The sides. I want my interface to look exactly like yours. I don't know what happened. I think this mine is at this side. Okay, you know what? Let's just work with this. I hope you can follow along. So I want everyone to right click on there's an interface at this edge of your or of your system rather, or let me say on your Eclipse platform. There's an interface here. So I want you to right click on your interface and select new. So just let me know if you're not following. Right click on your interface and select new. So that's what I should do, but then I can't do that now. So right click on your interface, select new, and after selecting new, select project. So it's going to open up a Java project wizard for you like this. So it's going to open up this for you. Can we all see this? Let me know that everyone can see this.
I can see it. Go on.
Okay. So it just ignore my screen. This is not coming up right now. I don't know how to bring it back. I'll figure it out, but I don't want that to take our time. So you would see this would come up, and then when this comes up, select Java project, and then click on next. So if you're following the book, you would see what I'm doing. I'm doing exactly what's in the book. Now when you click on next, in your project name, just type simple word count. So we want to count words, and then we want to call our project name simple word count. So simple word count. They said this name already exists. So I did it sometime ago. So I'm going to just put one in front of mine to distinguish it from the other one. And then, so you can just use simple word count because you've probably not done this. So after doing this, click finish. Finish. So when you click finish, it will probably bring up a dialog that shows you, do you want to do something that supports Java development? Just select yes. Just select yes. I need this thing to come up. I don't know why it's not coming up. Wow. This is crazy. Where is the manual? Okay, just a second. I need to just do exactly what you are doing. That place is not coming up, and there's no way I would explain that thing without it coming up. So just give me 1 second, please.
Hello, just to be clear, you guys, we're using Java product, right?
Yeah.
Okay, thank you.
If you've not gotten it to that point, you can. And if you understand the manual, you can keep moving on while I try to make my page look exactly like what is in the manual. So if you have the manual, you can move on. If you do not, you can just hold on. Let me quickly try to make my page look exactly that way so that I will follow along. Hi, Emmanuel. Are you here? Emmanuel.
I can hear you. Can hear you.
Okay, so this is my screen and I need it to look exactly like what's in the manual.
Abisala, can you hear me?
Yes, I can hear you. I can hear you. So this is my screen and I need to look exactly like what's in the manual. So I'm trying to bring up this part so I'll be able to explain properly and it's not coming up. I don't know how to bring it up. Can you hear me? Do you have an idea what I'm saying? Emmanuel. Emmanuel, are you there? You're on mute, just in case you are talking.
Hello, Abisala, can you hear me?
I got it. Thank you. I've gotten it. You did not help me when I needed you, so don't worry. I got it already. All right, everyone, I'm back.
I'm sorry.
No, apology not accepted. So everyone, I'm back. I actually was able to figure it out. So just in case you face same problem, right? Because anyone can encounter that kind of problem. I've never encountered it before. Just come here and open perspective. And when you open perspective, you would see like 4 tabs open. So you can delete, you can put off 2 tabs and then you have just the project tab and the packages tab left. And you can shrink to whatever size you want or expand as you wish. So, yep. I'm back, everyone. All right, so let's move on very quickly. I'm sure some of us have gone far, but then let me just move on. So this was what I created. So ignore this first one and let us look at what we created. So what you created has this. So what you're going to do is, okay, so you have this as what you created. I don't know why I have all of these files showing, but just ignore them and just follow along with what I'm doing. So now you are asked to right click on your project. So this is the project we created. So right click on your project and go to build path. Oh, you can't see my screen. Okay. So can you see my screen now? Can you see my screen?
Not yet, my boss.
Not yet. Oh, wow. Can any other person see it? I want to know if I should stop sharing and continue sharing.
I can see your screen. I can see your screen.
Oh,
I
okay.
can't see your
Sunday.
screen.
Oh, wow.
I can't. So I think you should stop and then start again.
Okay, let me stop and start again. So I've started again. How about now? Can you see it now?
Yes, I can. I can.
Okay, cool. All right. So, yep, I'm back. So let's continue. Sorry for the break in transmission. So this was what I created. Ignore any other thing you see. Just forget about these ones. This was what I created, right? So you all created simple word count. I created simple word count 1 because I already have simple word count created somewhere, sometime. So on what you created, that is simple word count, you would right click. And when you right click, go to build path. Oh, there's no build path here. Okay. There's something wrong with mine. Can you all see build path? When you right click, can anyone see it?
Yes, ma'am.
Oh, okay. So I'm the only one that can't see mine. I really don't know what has happened to my Eclipse. Okay. I have to exit it. I don't know what is going on. It's so funny how you do something sometimes and then you're doing the next time and it's not working out. But I'm sure that most of us are following. It's very explanatory. The manual explains everything. But for the sake of those people that are not probably with their manuals or do not have their systems at the moment, let me just try to make this work. And I just said we should go and get it done ourselves. But wherever we can stop today, I would appreciate if you can continue from there and make it work. This thing is still coming up. I really don't know. Okay, I think there's something wrong with mine. I don't know. Thinking of what to do, what we can do. We're wasting time already. Is Emmanuel still here? Emmanuel, are you still here?
Hello, Abisala.
Yeah. What is going on? I don't know. All of a sudden, I have funny issues, and I still did this yesterday, so I don't know what is going on.
Is that?
All of a sudden, I can't. Okay, for example, see this. I have to go to build part, and I'm not going there, and I'm sure every other person can do that. But for the sake of those that are not following, I would have just said we should go and do it ourselves. So I don't know why I don't have my build part showing. I think it changed.
I've been struggling with
What did you say? It changed my source or
So
something.
my network is bad. It's bad because I can.
So what should I do? Okay.
The network is bad.
Jesus. I didn't know I was on mute. I've been talking since. So I'm saying that I should have thought about this since. Now that mine is not working properly at the moment, let us use somebody else's screen. So is anyone sharing is anyone confident enough to share his screen? You know you are doing it, so we will do it along with you. So please, can you share your screen? Anybody? If you can, let me see your hand. I want someone to volunteer to share her screen or his screen. Okay, Hubert, thank you very much. So, okay, I saw Hubert first. Hubert, anyway, Hubert, can you share your screen, please?
Let's have Editorial do it, please. I like
Editorial,
when
okay.
Editorial shares her screen.
Oh,
I don't
okay.
mind. I want to.
Awesome.
Let's allow
Editorial,
him do it, please.
no, Editorial, you're going to share your screen now because I cannot go back to Hubert again. So, Editorial, please share your screen. We're going to do it along with you. Don't mind my VMware. I don't know what is going on. But then I'll figure that out later. But I can't troubleshoot anything now. So, Editorial, please, can you share your screen? Let me see if I have to allow you or something. I'm not sure. Try sharing. Let me see what happens. Emmanuel, network is really bad. I can hardly hear anything.
I said another person should share their screen, not editor.
Why? Okay. Cool. Thank you very much. This is what I want. Okay, so whose screen is being shared?
It's Hubert's screen.
Okay, cool. All right, so Huba, thank you for sharing your screen. So you're going to be teaching us today.
I'm not sure you want that.
Okay, so since mine failed to work, I'll just drop down. Then Hubert is the new lecturer for this class. Let's welcome him as he takes us what counts. So Hubert, so what are we supposed to do next? From our there's something we're supposed to do next. Yeah.
I think it's from the workbook. I can see. Yeah. We're supposed to I think we have to right click on this.
Okay, so everybody, let's right click. Don't take it too fast, though. So build path, then what? Configure. Configure
configure
build
build
path.
path, right?
Okay, yes. So configure build path.
Now the
Okay.
issue is I tried doing this already.
Okay.
Okay, it's true. It came perfect.
All
Okay.
right.
Then go to libraries.
Go to libraries. Yes.
Yeah, and I think you just click on. I don't know if you should click on this
So
or just to,
so what? No. What you're going to do now is you've gone to library, right? And then you
yeah.
want to add external jars. So jar files. Let me quickly say what jar files is. Jar files are used in Java. So it's jar is from Java archive. So J archive AR jar. So a jar file is a file format that is usually used to zip files in Java. So it helps you aggregate so many files together into one. It helps you with compression. So that is why jar files are very good. And if you notice, we are using a Java build path. So we are using Java to build our MapReduce program. So it's JavaScript we're using in our MapReduce program. So that's why we need jar files. We want our files to be aggregated into one. And the best thing to use are jar files. So we want to get our jar files. So now if you look at the path in your manuals, you will see user local/local/Hadoop, which shows you that you have to navigate to user directory. So now let's navigate to user directory. And to do that, we're going to go to let me see.
So am I doing anything? Am I doing anything on this particular page?
Yes, you do something. You want to add files. So you're
Okay.
going to add, yes. So you're going to click on add external
External
jars.
jars. Okay.
Yes. Add external jars. So this is where you're going to add your files from. So now let's navigate to the user directory. And the user directory is in the file system. So go to the file system. Go
Okay,
to the
file
file
system.
system. Yes. Now look for user directory. That's USR.
USR. Okay, I'm on USR now.
Cool. Click OK.
I think I still have to go into it. Also, click. Is it
Yeah.
like
So go to
click the
local.
thing?
If you know, look at the path number 1. Look at
Okay,
your
then
jar file number
local.
1. Follow that path that is
Okay,
there.
local. Then Hadoop.
Cool. Hadoop.
Then share.
Share.
Then
Then
Hadoop again. Then
common.
common. Okay, there's
Common
common.
is there.
Then lib.
Yeah. Then let's look for
API.
this.
It's a problem.
API.
Okay. Yes. Please hold on,
Yes.
Hubert. Just hold on me while let us speak.
Okay.
Yeah.
After clicking on add external jars,
External jars.
it didn't bring
Yes.
out any option. So it was just empty,
I
blank
know.
space.
They're using my screen now for this
Did you
course
go to
again.
libraries first?
Yes, I did.
You know what, Hubert? Carry this jar selection prompt and shift it to the other side. Shift it to the left. Carry it from the top. Shift to the left. Let me see what is behind. Okay, now bring this one out. Let's see that one well. Okay, so what did you say? What did you say happened?
After clicking on this add
External jars.
yes,
Yeah.
next window that came out was just empty.
Or just empty. Okay.
Yeah.
Can you go back? Cancel that prompt. Go back, right click on simple word count again. Let's see if it will bring the same error. Right click on simple word count again. Then go to build path, then go to configure build path. Then after doing that, click on libraries first. Navigate to libraries tab. Then have you navigated to libraries tab?
Libraries tab, yes.
Okay. Can you see exactly what is on the screen right now?
Yes, ma'am, I can.
Okay. So let's click on add external jars. Is it still the same thing?
Yes, ma'am.
It's not bringing up anything.
Nothing.
That's very weird. Okay, click OK. After clicking add external jars. Oh no, don't click OK. No, don't. And you're on Java build path. Check your sidebar. Is it Java build path you're on?
Java build path. I'm not seeing that here.
Exactly. So you're supposed to be on Java build path and libraries in Java build path. So what are you saying?
I'm not saying recently used then just selection.
Then there's something wrong. And
Okay,
you said,
maybe I will go over it again later.
okay,
So
maybe
I
you
don't
should go by
disturb the
it.
class. Yes.
Okay. All right.
Thank
So okay, you're welcome. You can just you can share your screen after the class.
Okay,
So that
ma'am.
I would see it. Yeah. So Hubert, so we want to get some jar files. These files were already put into our virtual environment by those that created virtual environment. So this is one of the files we'll be using. So yes, so that file API. So click it and select OK.
Sorry, before I continue, I'm noticing that most of the other files are also in the same directory.
Okay,
So I want to
yes,
ask if I can do
yeah.
multiple selections or
Control,
something.
yeah, control select them, yes. Control select all of them that are in that same, I think we have 4. Yeah, we have 4 in that same directory. So let's control select them.
I don't think control select works in Linux.
It actually worked for me.
Are you serious? I'm trying that now, it's not working.
Oh wow, that's funny.
So do I have to go one after the other?
Okay, just go one after the other. It will bring it to the same directory.
Oh,
Go one
man.
after the other.
Okay.
Yeah.
Okay.
Click OK. Add external jars.
Oh, sweet one.
Yes.
So the next one should be common
Commons.
CLI. Okay, this guy.
Yeah. Yeah. Okay. And then connections.
This guy, yeah.
Please, everyone, just try to follow along. Even if we can't do everything today, just try to follow along, please.
So in commons. What happened?
No, it remains. You okay? You have one remaining in that same folder.
I'm seeing commons. Configurations, yeah. This guy.
Yeah. Okay. We're in common already. No,
I think
1.6.
Okay, we have to go back now, right? How do I go back?
So okay, to go back, no, go to add external jars. And then now you don't want to go to the LID. Okay, you want to go to Hadoop folder, right?
So yeah, I think it's common. Is
it common? Oh, common folder. So that is it. So you just click on common. Click on that place. Yes, you're right.
I've clicked on it already.
Okay, cool. So you should see it there.
So Hadoop dash common. Okay, this guy then.
Yeah.
Show this to that. Yes. Okay. So,
and next one.
We have to go to Hadoop now, and then map reduce.
Yeah.
And then Hadoop blah 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 with the 2 on there.
So all these word files are just files for our example. So you probably have your own file if you wanted to do your own project, but then it's a sample. They are sample files for our project for today. Then I think that is all.
There's one more. Okay, the GRE system library must already be present. Okay. That's just
so I think it's present. Yeah. So that's GRE system library.
So what do I do?
So
okay.
Just click OK. Yes. All right. Cool. So let me just get I'm following from 2 people. Can I get?
I'm following.
Okay. Yeah. Who else? Anybody else? You're following. Ebube. Okay. Thank you. So I hope every other person is following, and if you are not, just check your manual and follow along. It's quite simple. So let's continue. So you're asked in 11 to expand the simple word count project and delete the SRC folder. So go to your project. There's an icon by the no, don't don't do that. Go to the icon. There's an arrow icon just at the back of that simple word count. If you look at the small arrow, yes. So click on it. That is the folder you have to delete, SRC folder. If you deleted that one, you start from the beginning.
Whoa. Okay. Wow.
Sorry. Yeah. So let's just delete that.
You're sure you want me to delete this? You're very sure?
Yes, SRC folder. Yes, I'm very sure.
There's nothing.
Okay. Yes, delete. So why are you deleting the SRC folder? Let me tell you why. So SRC is where Java IDEs are stored. And these Java IDEs, they store, it's like the source files. So all of these files that you loaded in, it's going to be stored in SRC. And then if you leave SRC there, you might have conflicts. So you have the files in SRC and you have the same files as files that you already put together in your simple word count. So that would bring a lot of conflict. So that's why you have to delete the SRC folder unless you need it for something. So the SRC folder is normally deleted to avoid conflicts when you are performing analysis. You can Google these things. All of these things I'm saying, just check online. Check, okay, why do I need to do this? Why am I doing this? What is this about? Be inquisitive. This thing is about being inquisitive. And then if you're inquisitive enough, you'll probably get answers to a lot of questions that you need answers to. So after deleting the SRC folder, we would now want to create a new source folder. A new source folder that doesn't have these files in them. So just follow the prompts to create a new source folder in 12. So check 12 and everyone should check 12 and follow. So that's exactly what Hubert is doing. So you follow the prompt in 12 and then in 13. Okay. Yeah, still in 12. Still in 13 now. Enter your folder name as SRC, which Hubert just did. So SRC and then click finish.
Why aren't we ticking these two boxes?
Okay, update exclusion filters in other source folders to solve nesting. Ignore optional compile problems. Well, we're not updating anything. We're not updating anything. And there's one thing about VMware. VMware is just for practice. So if you start updating stuff, you might have issues with your VMware. Ignore optional compile problems. We'll probably not encounter compile problems. So that is why I think we are just ignoring this. So
Okay.
yeah.
Assuming
So
that I
finish.
quit it. Okay.
Yeah, finish. Sorry,
Sorry.
Thank you. So we're done with that, and then now we want to create a class. So we need to create a class to be able to, because we are going to create different classes. These different classes are mapped out classes. They are the classes that would hold the different syntaxes that we're going to be writing. So we're going to be writing different kinds of syntaxes. Syntaxes to one syntax to map the words, another one to count the words, and so on and so forth. So now I want to create classes. So what we're going to do is just follow the prompt in 13. Select your file, select new, and select class. Select your new source folder, your new SRC folder. Okay, that's what you did. Okay, new and class. So create your class. So we're going to be using any class name you want, but then you're going to need, you can put mapper because you're going to create one for mapper. You're going to create another one for counts, and so on and so forth. For the name, why is the editor? Why is editor in the name? Okay.
I was looking for trouble.
Word mapper. Okay, so that's the package. We're going to be using package com.let's do big data. Your package can be anything, but you just have to make sure that that is the package used consistently in your program. So they've written this script for us, and these are the packages they used. That's why I want us to just follow this package name and this name that was used to create our Java class. So let's click finish. Finish. We're done creating our new class. So we have a new class, right? And then this is where we need to impute our script. So we have this package and we have this public class. So now we want to get the script for this word mapper. Now we don't know the script for word mapper for creating word mapping, but then it has been written for us, and then it's something we can learn on our own as time goes on. But then for today, we already have the script written somewhere for us. So let's just navigate to our folder. you were probably when you installed your 8 gig virtual environment Daska blah 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 thing, you probably had this file. There's this place that contains it says analyst WCBDA code scripts. Do you have something like that amongst the thing that you input into your system when you collected that 8 gig file?
I believe so.
Yes, please quickly check. Everyone, please quickly check in your
Where
folder.
the
Go to your
particular folder where I have it.
go to you have the folder you installed
On my Windows.
yeah, on your Windows. Go to your Windows. Just minimize and go to Windows.
Okay.
Minimize, no, minimize from here.
I'm not sure. I'm seeing it already. You can show it to you guys that I can see it anyway.
Okay. Okay, I get it. You only shared your
VMware.
VMware screen. Yeah,
Yeah.
I get it. So can you see the folder? Before I move on, please let me get yeses from 2 people and from 3 people. Just say yes if you are following.
Yes, ma'am.
Yes. Okay, who else? Another
Yeah.
person.
Yes, I'm
Yes.
following.
Okay.
What
All
exactly
right.
am I looking for in the folder?
Okay, so now in your folder, everyone, in your folder, you'll see something that is like analyst, WCBA code script, something
Yeah,
like
in the
that.
bracket.
Yeah, in the bracket. So click on that folder, and then in that folder, you would see intro, big data lab, MR, yarn, word count.
Yes.
Exactly. So that's where the script is. So they wrote the script for us already.
Okay.
This is just for us to learn, right? So let's just
open it and copy.
open up the text file. Then you will copy the mapper class code. That's the first code. That code is the one that is going to map your data. So we're supposed to do mapping, then reducing. So you're going to map your data. So this mapping, if you look at your code, okay, you know what? Just copy the code first. Copy the code under mapper class code. Then I'll explain some things in that code.
Okay, just the one under mapper class, not mapper
Yeah,
class.
under mapper class code. Yes.
Okay, it says package com.let's do big data, then colon. Is that all I should copy?
Package. So yeah, from package com.let's do big data to the 3 closing brackets. Yes, please copy that. And paste it here.
I will, but I'm looking for 3 closing brackets.
You can't find it.
Okay,
that's what ends the code. Okay.
That's the first part now.
Yeah, before the word reducer code.
Okay. So
please, someone else confirm that you saw this thing I'm saying. That Hubert is not the only one seeing it. Can someone else confirm?
I can see it now.
Okay.
Sorry, I'm a bit lost here.
Okay,
Can you go over it again?
Okay, you want me to go over where to get the file, the script from?
Yeah, because Hubert has not been moving anything on the system. So
I understand.
Okay,
so you know what?
Let me do something.
Okay, he wants to show you. Okay, cool. Thank you.
I think I can stop sharing this, and then I'll share my. What should I share now? Okay, I'll share this.
You can just share that particular part. Okay, cool. So see Hubert's screen. Okay, Hubert, please just explain.
Okay, so first off, let me go to. Okay, I have everything in my Octave Analytics folder. So it's inside big data. Then there's Analyst CBA DA, like you talked about. So inside that, you go down to this particular one that we're talking about today. Okay. Let me go back to the one. This guy with the word count. So if you double click on word count, I'm not sure you'll be seeing this. Let me show you.
Okay, I've seen it.
Okay, cool.
You're going to see text. So hold on,
it's a text file.
The text file.
Yeah.
Okay.
So this is the file you see. Okay. So you select from package all the way down to this place. That's the code that we're copying.
Yes.
So you copy
for
that.
The mapping.
Okay. Yeah, for the mapping. So then you come back to your VMware. So where do I drop that?
Okay, so just drop it on top of. I don't want this public class word mapper thing. Leave it. The only thing that should be on your screen before you drop it is package com.let's do big data. Every other thing, yeah. So yeah, drop it on that. Yes. All right, cool. So okay, package.com is repeated twice. So let's just take out one of them. All right. So very quickly, let me just explain some simple parts of this whole script.
Okay.
Now, you are importing some files, and these files you're importing, they are, of course, when you're programming, you have to import files that would enable you perform what the task you want to achieve. So we have the one that you would, the ones that will help you to write in your data. We have the ones that will help you to show that it's a text file. The ones that will help you to reduce, that's the map reduce, that's the mapper.
Okay.
And then your public class mapper. Now, if you look at public void, you would see map long writable key text value, something like that. Now, if you remember when Emmanuel, okay, I don't know if Emmanuel touched it, but then your mapper does something to your data. Our time is fast spent, so I'll just tell you what to do with the rest, and then we're done for the day. So you can go back and check it out. So there's something your mapper does to your data. So your mapper function takes a part of the data, right? Then okay, for example, now I have so many words. Text. I have a lot of text. What a mapper function does is, what this mapper function will do is it will make it into a key value pair. So it will take, for example, I have good, I have tasty, I have chicken, I have pepper. Those are words in my text file. So what it does is it takes chicken, it maps chicken, it writes chicken, comma, 1. So it counts chicken as one word. That is what the mapper does. So the mapper maps your data into key value pairs. So you have the name, which is the word, and then you have the key value, which is 1. So we have 1. Count of chicken is 1. Then it takes the next one, say good, counts it and writes good, comma, 1. So it does this into triangular brackets, each of them into a very long list. So it converts your data into a very long list in key value pairs. I wish I could. Okay, you know what, Hubert, can you go to the next line? Go to the next line of this script. I just want to quickly show something. You delete it. Then put a less than and greater than brackets. A less than and greater than sign. Inside your less than and greater than sign, write good, comma, 1.
One figure or one word?
One letter. Sorry, number. Number 1. Yes, go to the next line. Write something else. Probably write tasty.
The same thing.
Yes, same thing. Tasty, comma, 1. You can use tasty or something. I'm just trying to explain what mapping does. What did Adetoro do to you? Write 1. Write 1. Write 1. 1. Then go to the next line. Write good again, comma, 1. Now, this is a key value pair. So this is what I'm trying to explain, that when you have your data, it takes each of these words and counts them as 1. So it's even the words that repeat themselves, it takes it again, just like it did good here. It takes good again, writes 1. If there's another good somewhere, it still takes good and writes 1. So 1, 1, 1, 1, 1, 1, all through. So mapper converts your data into a key value pair. It converts your text data into a key value pair. Then the reducer is the one that takes your data and combines the similar ones together. So then in your reducer, you'll be having something like good, comma, 10, because you have 10 goods in your data. Then you can have additorial, comma, 2. So you have additorial appearing twice in your data, and so on and so forth. So this is what mapper does. Mapper converts your data into a list. A list, a form of key value pairs. So that's just the point I'm trying to make. So that is why you have key text value. Context. It's just trying to tell you that you're converting this thing into a key value pair, your key and your text value. So this is the form of text. Ignoring the one is a number, but it still takes it as text. So your input value is a text, and your output value will still be a text. But then it counts it as a number. So that's basically what it's doing. So if you see, it's splitting your data, split, trim, split, and so on and so forth. So you can take your time to understand this code, check more about it. But that is just basically what your mapper script is doing. So Hubert, you can delete that part we wrote out. And so similarly, you do this for all your other functions. So let me just quickly say this before we call it a day. So you have your word mapper. It's already saved there. So next you create another class. So we have different classes. So now we want to create the word reducer class. So we have the word mapper class. We'll create the word user class, and we'll create another class that will count our data. So now let's go to new class. Go back to your data. Click com dot let's do big data. Right click it and select new class. So you want to create another class now. Another class. Yes. So the same thing you did before, you do it again. So now you are going to create a word reducer class as shown in your manual. So create a word user class.
So word reducer or word
Yes, word reducer. That is 15. If you check 15, you understand what I'm saying. If you go to 15, yeah, 15. Word reducer class. So, and then click OK or finish. Awesome. So the same thing you did, go back to your script, take the word reducer script, put it into this and save it. Then you create the third class. So all of these scripts are the things that are going to perform your word count for you. So you break it into steps. We have different steps: mapping, reducing, then counting, and so on. And then when you're done with that, you can export your data. So I will have to close the class for today, but I think I've explained the basics of understanding how you can make use of the VMware, how you can do your word counts, and if you have any questions, you can always ask me next week. I'll be willing to answer you, but I will only take questions when I know that you've actually tried it and you faced issues. I said next week, sorry, I meant Wednesday. So I would only answer you if I know you've tried it and then you have questions. So you can do the same thing and follow through with the manual and complete this project. I'm sorry for wasting your time. I don't know what happened to my Eclipse all of a sudden. I still opened it this morning to be sure that everything was working fine. So it's not intentional. Pardon me. So sorry for the delay. I just wanted us to finish this today, but we're not able to. But I would like you to please go back and complete this task, and I would appreciate feedback on Wednesday on how well you were able to complete this task. So if you have any other questions, let me know. Hubert, thank you very much for sharing your screen. You saved my life. Oh, you did not save my life, you saved our lives. Oh, my life. Okay, whichever way. Okay, so any questions from anyone? I hope we all followed. Please tell me you followed. Anybody? Tell me, like 5 people. Just tell me yes, yes, yes. I followed.
Yes,
Yeah,
yes.
we all followed. It was
Yes, I did.
very
Yes, I
interesting
follow.
class.
Okay, all right, cool. Thank you very much. Okay, any questions before we call it a day? It's 12:11 and I don't like keeping people. Any questions? Does this mean there's no question? Or if you have a question, raise up your hand so I'll be able to know. Okay, cool. Ebube. Before you proceed, pronounce your name. I want to be sure that I'm pronouncing it properly.
It's Ebube, you're correct. Yeah, you
Ebube.
pronounced it correctly. Yes.
Okay.
Ebube.
All right, cool.
So I just wanted to ask, will all we are doing on Hadoop for Hadoop on its own, is it going to be Java that will be writing in Octave? Or
okay.
Yeah, like throughout the program. Is there any Python, anything, or
On
that's
Hadoop.
what I would ask. Yes.
Okay. So for Hadoop, you can write R on Hadoop and you can write Java. That I know about. You can write Java and you can write R. Java is very good for word counts such as this. R2 can be written on Hadoop. You can use R on Hadoop to perform analytics, to do regression, modeling, analysis, advanced analysis, and so on. You are still going to do it after learning R. We are still going to go back to Hadoop. Now we'll be learning R Hadoop. That is what we're going to do after knowing R, because it's like an advanced learning of R. They are learning R with Hadoop now. So I know about using Java with Hadoop. I know about using R with Hadoop. So this is just, you're using Eclipse as a platform. But of course, you can see that we're using Java. Most of the scripts we're writing are Java. We're even using Java files, which shows that we're using Java, right? But then we're going to use R with Hadoop. Those two I'm sure about. So we can always check for other applications that can be used with Hadoop. So
Okay.
I hope I answered your question.
Yeah, thank you very much. I just like to ask again, when you were starting the lab, you mentioned something like Eclipse was based on MapR. So we use it to map reduce. So I would like to ask, is MapR something different from MapReduce, or MapR simply means map reduce?
Okay. So Eclipse is used to write MapReduce programs, and the tool it uses to write MapReduce programs is called MapR.
So the
So
R there is for
MapR is like a tool on Eclipse that helps you to write MapReduce programs. So you can it's popularly used with MapR. I don't know, there could be other things you can use Eclipse with, but then Eclipse is most of the time used with MapR, and this MapR is what helps you write your MapReduce program. So you're asking me if MapR is the same thing as MapReduce. Of course, I think it should be. It shows MapR is MapReduce, so you're reducing something. So MapR is probably gotten from MapReduce. You're using something to do MapReducing, right? So MapReducing. So we call it MapR. I think that's just it. So it's basically the same thing, but then it is used on Eclipse to perform MapReduce programs. Do you understand?
Yeah, I understand. Thank you.
Sorry, ma'am. So MapR is more like the language.
Yes. It's like the language used. It's like the language used on Eclipse for MapReduce programs. Yes, I think I referred
Okay,
to
and it
the
cannot be used on any other software outside Eclipse.
Software. Okay, apart from Eclipse. That I'll have to find out. And what I know is using Eclipse for MapReduce programs, and Eclipse is very efficient for that. So for using MapR on other programs, I'll have to find that out and get back to you. You can also find out too and tell me.
Yes,
I would appreciate if you can even tell me too. So
okay, ma.
Yes.
Thank you, ma.
You're welcome. Yep. Any other questions? Does anyone want to say anything? Okay, no other questions. So 12:16. Wow, we've spent so much of our time. So please do the MapReduce counts, complete it. If you have any issues, let me know. If you have issues, try to solve them. Don't always wait for me to solve them for you. And then we'll call it a day for today. Thank you very much, everyone. And thank you for your patience and your time. I hope you learned something today. Thank you. Bye.